Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, a little bit of snow. Hey there, this is lesson 25, incredibly useful ratios, incredibly useful, not just a little useful, it's just incredible how useful these ratios will be. Very incredible. Exercise 1 through 3. Use the right triangle, ABC, to answer these exercises 1 through 3. Name the side of the triangle opposite angle A. The side opposite angle A is side BC. Okay. Name the side of the triangle opposite angle B. The side opposite B is the other two letters in the name of the triangle that does not include B. Think of it that way. There's 3 angles in a triangle. The side opposite is the other 2 letters. So if I'm going to say angle C, the opposite side's AB without even looking. Okay, opposite C, AB. Okay, so there we go. Exercises 4 through 6. For each exercise, label the appropriate sides as adjacent, opposite, and hypotenuse with respect to the marked angle. Marked acute angle, not the right angle. Okay, so this is angle F, and adjacent, opposite, and hypotenuse. Well, we know the hypotenuse is the longest side by definition. The hypotenuse is the longest side of a right triangle, and it's the side opposite the angle that's right. And angle D is right, so FE is the hypotenuse. So that's the hypotenuse. The side opposite angle F is DE. So therefore, by process of elimination, the side that is used to form the angle we're talking about is called the adjacent side. And there we have it, done. And okay, so now we're talking about angle R. Opposite the right angle is hypotenuse. And now I'm just going to use abbreviations. The side opposite is over here. And the side that is used to make the angle that's R is adjacent. Okay, you might think of that other side that's used to make that angle as an adjacent side, but that's the longest side, so we don't call that adjacent, we call it a hypotenuse. Okay. Okay, page 2, diagram 6. We're doing the same thing we did on the prior page. There's the angle, there's the right angle. The side opposite the right angle is the hypotenuse. The side opposite angle K is opposite. And the side that is used to make that angle or form it is the adjacent. So there we have it. Exploratory challenge. Note, angle measures are approximations. For each triangle in your set, determine the missing angle measurements and side lengths. Side length should be measured to 1 decimal place. Make sure that each of the adjacent over hypotenuse and opposite over hypotenuse ratios are set up and missing values are calculated and rounded appropriately. Okay, so here's group 1. We have a triangle called triangle ABC. And opposite over hypotenuse is 12 to 13, and adjacent over hypotenuse is 5 to 13. Then the length measures, I'll do those first. Okay. So the first thing we need to do is look at how we're going to name this. Okay, let's do the length measures first. So these are the lengths of the sides of the triangle. We have a 12, we have a 13, we have a 5. Opposite over hypotenuse. So the hypotenuse is 13. Adjacent over hypotenuse. The hypotenuse is 13. So if I have a right triangle, let me just explain this one time. If I have a right triangle like so, and I know my hypotenuse is 13. So this is the right angle we're talking about here. And so angle B is our right angle. So that is 90 degrees. We're looking for angle measures. So if I name this A, B, C, let me just think about this a moment. Then AC is 13. So I'll put AC equals 13. Then we would have, if we're talking about angle A, so I look down here, then I'm trying to figure out how they're deciding which angle they're going to talk about, angle measures. Well, they're only giving one, I guess we'd have to find the other two. Okay, so here's angle A, here's B, and here's C. Opposite B is AC, and that's 13. Opposite over hypotenuse, the opposite to A is 12. That'd be over here, and that is BC. So BC equals 12. And as they're looking, I'm looking down here, I see centimeters. So I guess I'll use the same unit of measurement in the rest of the diagram. So that leaves us AB as being 5 because it's adjacent over hypotenuse, adjacent 5 over hypotenuse 13. So that gives us the side length AB equal to 5 cm. All right, so now we have to talk about angle measures. Okay, so I've got the calculator out because we need it. And now, of course, when I start writing, it's going to disappear. There you go. Anyhow, now we want to find a measure of an angle. Let's do angle A. So the measure of angle A, let me just stay with green. The measure of angle A equals, well, this is 90, and I know A is acute. And so is C. They have to be because we have a right triangle. A right triangle has two acute angles because we have to have a sum of 180 degrees. So I know it's less than 90, but is it 89? Is it 1? Is it 2? Is it 40? How do we figure that out? Well, opposite over hypotenuse in trig is called sine. Okay? And adjacent over hypotenuse is called cosine. So we use an abbreviation when you don't use the letter E. And in cosine, we don't use IN either. So it's just sine and cosine, SIN-COS. Sine is the ratio opposite over a hypotenuse. So the measure of angle A equals the sine of these. So the sine of angle A equals opposite over hypotenuse, which is 12 over 13. Okay, so when I'm doing opposite over hypotenuse, I'm talking about the sine of A. And then to put that in my calculator, I have to get angle A by itself, and to move sine over to the other side, we have to do an inverse operation. Okay, it's just like every other math problem we do, solving an equation for a variable, if you will. We're trying to solve for angle A, so I have to move sine over to the other side. So then I'd say angle A equals, and then when I move the sine over to the other side, the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of squaring is the square root, and so on and so on. Well, the inverse of sine is just that. It's called sine inverse, and it's taken to the power of -1. So that angle A is going to equal the sine inverse of 12 over 13. Okay, so when I go to my calculator, and the sine button is right here, and if you look right there in blue, it says sine to the -1. Well, anything in blue in the calculator tells you to use this blue second button. So I hit second, and I hit the sine button to get sine inverse, and then you put your fraction in there. 12 divided by 13. There's my fraction. And when I hit enter, that's going to give me a degree measurement. Now, before I go any further, I'm going to click on mode. Make sure you are in degrees, not radians. So if your calculator says radians, come down here, arrow over to degree and hit enter. and then go back and do your calculation. So this is approximately, so I'm going to do an approximately 67 degrees. Now let me point something out to you. You could have used cosine as well. Remember, I told you up here, cosine's adjacent over hypotenuse. So I'm going to say the cosine of angle A equals, well, cosine of A is adjacent over hypotenuse, 5 over 13. It's right here. So I'm going to put 5 over 13. Move cosine over the same way we did, we get angle A equals the cosine inverse of 5/13. So if I go to my calculator and I do the second cosine of 5 divided by 13, can anyone guess what the answer is going to be? It's the same angle, so it should be the same measure, and it is. Okay, so that's how we're going to do those. Okay, triangle DEF. The measure of angle D is 53 degrees. DE is 3 centimeters. EF is 4. DF is 5. The longest side is your hypotenuse. So if I do hypotenuse, opposite over hypotenuse, you see this? Adjacent over hypotenuse, I'm going to put the hypotenuse in the denominator. DEF, the measure of angle D. The side opposite angle D is EF. There's no D in the name EF, so the opposite side to angle D is EF. Opposite is here, so this is 4. Adjacent has the letter name D in it. DE is 3, so that's going to go over here. And then we do an approximation, and that's going to be 0.8, right? 8/10. And 20 times 5 is 100. 20 times 3 is 60. That's 0.6. And I'm doing an approximation here, and it's actually an exact in this case. So I'm going to use equal signs. So that's 0.8, and this is exactly 0.6. Okay. Okay, number 3. We have a triangle GHI. The measure of angle I is 41 degrees. GH is 5.3 centimeters. And it's up here. So that's my opposite. That's got to be opposite I. So if I put I here, GH is opposite I. And what is 0.75 as a fraction? It's 3 over 4. So there's the 3 sides. So if our hypotenuse is 4, then our hypotenuse is 4 here as well. Okay, so this is like a little puzzle. We've got to figure out how we're going to find these values. Look for a fraction you know. And then 3/4 is 0.75. So now I know my hypotenuse is 4. So a 4 goes here. It's 13, 13, 5, 5. The denominators are always the same. 8, 8, 8.5, 8.5. All right. So then we have a side length GH. We have a side length HI. And we have a side length GI. Those are the 3 sides. The measure of angle I is 41 degrees. The hypotenuse is 4. So I'm going to put a 4 over here. And it might help to have a diagram to do this. I'm sorry, that's not right. The hypotenuse is 4. The side opposite I is GH, that is 5.3. And the adjacent side is 3. It's right here, adjacent over hypotenuse, 3 over 4. So there are our numbers. And now we just need to name these properly. So opposite the 90 degree is my hypotenuse. GH is 5.3. So GI is over here. So the G has to go here. H has to go here. Okay. All right. So I'm just thinking here, 13, look at 13 here. AC is 13. What letter wasn't used? B. Where is B? It's in the middle. DEF. The longest side was DF, opposite the right angle. DF, what letter's not there? E. Angle E is in the middle. That's our 90-degree angle. H is our 90-degree angle. Okay. The measure of angle I was 41. Then we can find G, but it doesn't ask for it. HI is 3 cm and GI is 4 cm. Okay. Okay, number 4, I just cleaned this up, brought this down. The denominator is 8, denominator hypotenuse 8. KL is 6.93, JL is 8. So JKL, JL, it has to be the hypotenuse. So that's how come I named it JL. And so therefore by elimination, that's got to be K, the 90-degree angle. So JL is 8. That is the hypotenuse. KL is 6.93. Okay, this time we don't know JK. Before this, we were given all 3 sides. We had to find the other 2 sides, but we can use the ratios to find these, but we only have the 8. So how do I get 0.87? So if this is X and I multiply both sides by 8, these 8's cancel and I find X. So if I get my calculator and take 0.87 times 8, then I get 6.96. Okay. I have 6.93. That's KL. 6.93, if we're talking about angle L, so we're going to say the measure of angle L equals, if we're talking about angle L, adjacent over hypotenuse, so this is 6.93 here. So I put it in my calculator and we got, what did we get? I erased it. 6.96. So it's off by a little, but that's the value they gave us. 6.93, and hence this approximation. When I put it in the calculator, it's 3/10. So this 0.87 could be 0.86 something or 87 something. So that's why it's an approximation. So anyway, we have 6.93. How do I find the length of the third side? So we have JL, which is 8. We have KL, but what is JK? Okay, and this one I'm going to do the Pythagorean theorem. So JK is my A squared. So A squared plus B squared, 6.93 squared, has to equal 8 squared. Okay, 8 squared. I was thinking 64 in my head and I wrote a 6. A squared plus, and if I take that 6.93 and square it, I get 48.44. Equals 8 squared, which is 64. So if I subtract 48.44 from 64, I'll just use the whole thing to make it more accurate. I'll get 15.56. So A is 15.56. Okay. A squared is 15.56. Okay, 1 second here. I don't like squeezing. All right, so let me just do this again. I just had to get that out of the way. So I have A squared plus 6.93 squared equals 8 squared. A squared plus 6.93 was 48.44 equals 64. Then I subtracted 48.44 from both sides and got 15.56. Take the square root of those and I get A to equal. And I go square root, second answer, enter, and I get 3.94 approximately. Okay, so 3.94. Okay, so how do I find this here? JK 3.94. We're talking about angle L. Opposite over hypotenuse is 3.94 divided by 8. So if I take this 3.94, it's in my calculator already, and hit divide by 8, then I get 0.49. Okay. All right, next one. Let me erase this. Now we're doing triangle MNO. Let me erase all of this. We're using the same triangle. Now we have triangle MNO, and if I look here, my hypotenuse is 8.5. If I'm going to call this the angle we're going to talk about, which will be the angle M, the measure of angle M equals, oh, I never did the measure of angle L in the last problem. Okay. So the measure of angle L equals the sine inverse of my fraction, 3.94 divided by 8. So if I go in my calculator and do second sine 3.94 divided by 8 will give me approximately 29.5 degrees, or let's just say approximately 30 degrees. So this should be 30 degrees, and it's an approximation. All right, now let's move on to this problem. Sorry about that. The measure of angle M equals, we'll leave that blank for now. We know that the hypotenuse is 8.5, and if M is our angle here, this is M, then N is here, and O is up here. So we have the sides MN, we have the side NO, and we have the side MO. MO is 8.5. We already know that from the hypotenuse here. So remember, I don't have it on my screen anymore. There we go. Adjacent over hypotenuse. So if this is adjacent, that's NM. This is 7.5. Opposite of M is my ON, which is 4. Okay. All right. Now, all we need to do is find is the measure of angle M. So I'd say the measure of angle M equals the sine inverse of, and remember sine is opposite over hypotenuse, so I take this fraction, 4 over 8.5. And then when I put that in my calculator, second sine, 4 divide 8.5, enter, I get 28.07 degrees. So I'll say approximately 28 degrees. Okay, this is page 2, or is it page 3? Page 3, I think. Yes, page 3. So in the classroom setting, it was grouped. So one group was going to do the last page, and the next group does another page, and then the partner discuss what you can conclude about the pairs of the triangles between the two sets. So I'm just going to do these. We're not going to do any of those comparisons, but I'm just going to do this, and I'm going to speed it up a little bit because we've done these. And so I'm going to mark this as sine because that's opposite over hypotenuse, and this is cosine, which is adjacent over hypotenuse. So triangle ABC, I'm going to put the measure of angle A. Now we just have primes. And that's going to, well, let's do an approximation. So how do I do that? First thing I'm going to do is I'm going to set up my right triangle. The hypotenuse is the easiest one. It's always the denominator, 6.5. And let's just use this as what we call a reference angle every time. And opposite the reference angle is opposite, which is 6. And adjacent to the reference angle is 2.5. Obviously, these are not drawn to scale. This is an isosceles right triangle, but just assume these are not drawn to scale. This is length 2.5, this is length 6. So if this is angle A, then this is B, and this is C. So now I can answer all these questions. The measure of angle A equals, So I could do the sine of this or the cosine of that. It doesn't matter which one you do. So I've been doing sine over and over. This time I'm going to do the cosine inverse. So I'm going to say the cosine inverse of my adjacent over hypotenuse, which is 2.5 divided by 6.5, will give me 67.4 degrees. So let's just say approximately 67 degrees. And then the measure of the lengths, well, we have A prime, B prime, we have B prime, C prime, and we have A prime, C prime. So AB is 2.5, BC is 6, and A prime, C prime is 6.5. Okay, and those are all centimeters. I'm not going to write centimeters just because it's hard to write with this pen, and I will continue to the next problem. So let me erase these. Use the same triangle, switch colors to blue. We have a triangle D prime, E prime, F prime this time. E's the right angle, I believe. D prime is 53 degrees we're given this time. D prime, E prime is 6 centimeters. EF is 8 and DF is 10. That is our hypotenuse. Just make sure that the letter that's not in this name is opposite the right angle. DF is opposite E. And so that's a 6, 8, 10 right triangle. It's a special right triangle. And we need to find what else? Nothing. We just have to fill these in. So the opposite of D is 8. And the hypotenuse is 10. And that's going to equal 0.4. Just kidding, 0.8. 8/10, 0.8. And then we're going to take adjacent over hypotenuse, and that is going to be 0.6. Okay, so there's that one. Switching colors, erasing, moving along. And now we're going to do it in red. And we have the angle, 41 degrees. We have a right angle. This is our reference angle. And G prime, H prime, the measure of angle I is 41. So this is going to be called triangle GHI. GH is 7.9. That was given. That is our opposite. So it's opposite of I. So I have 7.9 divided by something equals 6.66. So if I have 79 over X equals 0.66 over 1, and I cross multiply, I get 0.66. X equals 79, and I divide by 0.66, and I get my X. So it's 79 divided by 0.60, 7.9. I forgot my decimals here. 7.9 divided by 6.6. 7.9 divided by 0.66 equals 11.97. Okay, so there's my X. 11.97. Well, guess what that is? That is the hypotenuse. It's the denominator. So this is going to be the same, 11.97. So now I need to find the numerator. Let me get rid of this. Let's call the numerator y. So we have y over 11.97 equals 0.75. To get this, we multiply both sides by 11.97. So 0.75 times 11.97 is 8.97 or 8. Okay, 8.97 or 8. Let's see. Let's just say 8.97. Okay, could round that to 9, I suppose. And we could have rounded this to 12. So let's do that because we're only off by hundredths. So instead of putting 11.97, let's just call it 12. And let's just call this 12 because it is an approximation. So that's okay. Because going out to a few 100ths of centimeter really doesn't make that much of a difference. So 3/4 is 9/12. Okay. So there we have it, 9/12. So now we have to name these. So G prime H prime was 7.9. H prime I prime is, and these are supposed to be primes, H prime I prime is adjacent 9. And then finally, the hypotenuse GI. G prime I prime equals, let's just call it 12. Rounding. Okay. And then this was 9. All right. So there's that one. Now let's move on to another one. Get rid of that information. And I will use purple this time. Just looking at this real quickly, I see that 12 is in the denominator. That is my hypotenuse across from my right angle. And this triangle is triangle JKL. Okay, so if I put J here, K here, and L here, oops, 4. What am I putting a 4 for? L here, L prime, prime, prime. LJ, or JL, is 12. Okay, so I'm just verifying I named this correctly. 12 goes to J prime, L prime, and there it is right there. KL is 10.4. Well, that's the opposite of J. That's opposite, so that's going to go here. 10.4 divided by 12 is 0.87, approximately 0.87. And then to get this answer, oh, look at, we already have 0.87. So 12 and 0.87, 12 and 0.87, this has to be 10.4. Okay, so that is an easy one. So JK prime is also 10.4 centimeters. So this is 10.4. So this is an isosceles right triangle. So when that happens, I don't even have to do the angle measurement thingy. I don't have to do the sine or cosine of these. I know that these are congruent because the sides are congruent. So we know that these angles are congruent. Base angles of an isosceles triangle are congruent because their opposite sides are congruent. So the measure of angle J prime equals 45 degrees. Okay, I want to look at number 4 again. So I'm going to leave this here. Actually, no, I'm going to erase it. I'm going to do it again, but I'm going to do it the other way around. So watch what I'm going to do here. So I'm going to remove this J here and this L here and switch them. So let me do this and let me name it. I just want to show you something. If I name this L and this J. So JL is 12 and we were given that. So it's still JL, but we switched the J and the L. But now KL is 10.4. So now that with respect to angle L, now if I put the measure of angle L here, last time I had J, then adjacent over hypotenuse is 10.4. And if I do the Pythagorean theorem, that's why I got thinking about this. The other way didn't work. If these were both 10.4, watch what, this is why I'm doing this again. 10.4 squared plus 10.4 squared has to equal 12 squared. Well, 10 squared is 100 and 10 squared is 100. That's 200 and 12 squared is 144. So that didn't work. So that is another way of checking to see if you set these up correctly. So now I have the measure of angle L down here and I'm calling L KL 10.4 being adjacent, not opposite. And then I'm going to check again. So I have 10.4 here. So now do the Pythagorean theorem to find JK. So JK I'll call X squared or A squared, it doesn't matter, plus 10.4 squared equals 144. I just multiplied our 12 squared. So 10.4 squared is 108.16. So x squared equals 108.16, 144 minus that. And that is 35.84. So this is 35 point, no, not 35.84. What am I doing? I didn't do the square root yet. So the square root of my answer is, whoops, square root second answer, enter, is 5.98 or about 6. So let's just call it 6. It's 2 100ths away. That is 6. So this would be 6 here. And the sine of 1/2, which is 0.5, 6/12 is a half. The sine of 1/2 is 30 degrees. You can check that on your own. Okay, so that one works. Okay, let's move on to the last one, number 5. Let me erase this info here. Erase everything off of my, and let's use blue, I guess. This is the right angle here. All right, 17 is our denominator. 17 is our hypotenuse. So if this is our angle of reference, adjacent is 15. Opposite is 8. 8 squared 64, 15 squared is 225. 225 plus 64 is 289. 17 squared is 289. Okay? The measure of angle M equals, so we're going to call this M, N, O. So we have sides M, N, N, O, and O, M. And O, M is 17, N, O is 8, M, N is 15. Okay, all we need to know is the angle. So if it's this angle, we can do opposite over hypotenuse and take the sine inverse, or we can do adjacent over hypotenuse and do cosine inverse. I'm going to say the measure of angle M equals the sine inverse of opposite over hypotenuse. And that is going to equal second sine 8 divided by 17, enter, and it's about 28 degrees. Okay, so then it says with a partner discuss what you can conclude about each pair of triangles between the two sets. So if we look at this, you should have gotten the same values. Okay, you were just given different parts in each one. Okay. I forgot to open my shutter. Oh, well. All right. That's okay. All right. Page 4 brings us to exercise 7 through 10. For each question, round the unknown lengths appropriately. Refer back to your completed chart from the exploratory challenge. Each indicated acute angle is the same approximated acute angle measure as in the chart. Set up and label the appropriate length ratios using the terms opposite, adjacent, and hypotenuse in the setup of each ratio. So pause the video, see if you can do this, come back, and then we'll talk about it. Okay, so if we take the term opposite divided by the hypotenuse, and then we come over here and we say adjacent divided by the hypotenuse. And this is our, it's called a reference angle. The angle that we're referencing an angle and the sides with respect to that angle, it's called the reference angle. So the opposite of 53 is Y. Opposite of 53 degrees is Y, and the hypotenuse is 7. Okay, so it says, refer back to your completed chart. Each indicated, set up and label the appropriate length ratios using the terms in the setup of each ratio. Okay. Adjacent over hypotenuse would be X over Y. And that would give us y when we did the calculation. And this would give us x. Oops, I put a y here. It's x over 7. I don't know what this is doing. Never mind. Escape. Okay, let's try that again. That should be a 7. Here is the reference angle adjacent over hypotenuse, x over 7. Okay, I'm not going to put that. So there's the ratio setup. All right, next one. Just change colors. Here is our reference angle right here. So if I do opposite over hypotenuse, the opposite of 30 is 9.2, and the hypotenuse is z. Okay, and if I do adjacent over hypotenuse, then I get this side is adjacent to the 30-degree angle, x over z. Never put the hypotenuse in the numerator. It's always opposite over hypotenuse, adjacent over hypotenuse. Hypotenuse is always your denominator, and don't confuse adjacent with the hypotenuse. Yes, the hypotenuse is adjacent to the angle, but the hypotenuse is longer, so that's always called the hypotenuse. All right, and the last one, my reference angle is a 67-degree angle, and if I'm looking for opposite over hypotenuse, then the opposite is 21.6, and the hypotenuse is z. And if looking for adjacent over hypotenuse, then that's going to give me x over z. Okay, now that I've set all those up, now we're going to solve these. So I just wanted to set them all up first. And if I look at this 53-degree angle, this got the sides of 7, y, and x. So if I go back to my chart, the 53-degree angle, hello, the 53-degree angle is number 2, 53-degree angle. So we have 0.8, we have 0.6. And what are we trying to fill in here? All right, so look at 7, and we have 53 degrees. Opposite is y over 7. So I go and look at my opposite over hypotenuse for the triangle that I have a 53-degree angle in. So I go here, I can go use either one. So I'll use this one. I have 8 over 10. So opposite over hypotenuse is 8 over 10 in this triangle. So I'm going to say equals, or it's just equals 0.8. 8 over 10 is 0.8. Okay. So then I'm going to multiply both sides by 7, and I'm going to get y equals 5.6. Over here, I have x over 7. And if I go back to that 53-degree triangle from the table, cosine 6 over 10. So then I set that equal to 6 over 10, or 0.6, either way. Let me just do it as 0.6. It's easier as a decimal. And then x is going to equal 7 times 0.6, which is 4.2. Okay. And then if I go to the 30-degree triangle, and I go up to here, the 30-degree triangle here, and my opposite over hypotenuse is 6 over 12. Well, that reduces to 1/2 or 0.5. So if I go here and I set that equal to 1/2 and cross multiply, then I get z equals 9.2 times 2, which is 18.4. So then over here, I can say that is going to give me x over 18.4. And then I go back to my other cosine, and that's approximately 0.87. So I'm going to set that equal to 0.87, or not set it equal to, I'm going to, yeah, equal to 0.87. And then I cross multiply. So my X is going to equal 18.4 times 0.87. So it's 18.4 times 0.87, and I get 16. Don't worry about that 0.0008. It's just close enough to be 16. So Z is 18.4 and X is 16 in this situation. So we're just using our table to answer these questions because the reference angles are equal. That's all this is. So we have opposite over hypotenuse. And if I go back to my 67-degree triangle, 67 degrees is number 1. Opposite over hypotenuse was 0.92. So then I bring that value over here and I say, well, opposite over hypotenuse is equal to 0.92. So this 21.6 Z is equal to 0.92. Cross multiply, and I'm going to get 0.92 Z equals 21.6. So Z is going to equal 21.6 divided by 0.92. And I get 23.48 for Z. I shouldn't be using equal signs. They are approximations. So then when I do the adjacent over hypotenuse, I go back here and the adjacent over hypotenuse was 0.38. So I put that in here. That's going to equal 0.38. XZ is going to equal 0.38. And my Z is 23.48. So now I can say X over 23.48 equals 0.38. And then when I cross multiply, I get my X. 23.48 times 0.38. So there it is right there, times 0.38. It's just an approximation. It's 8.9. So that's approximately 8.9. So we use the table to finish this, is all that was. Number 10 says, from a point 120 meters away from a building, Serena measures the angle between the ground and the top of the building, and it's 41 degrees. There's our reference angle. What is the height of the building? Round to the nearest meter. So this is opposite, this is adjacent, and this is the hypotenuse. Okay. All right. So what we're going to do next is we're going to do the same thing we did up above. We're going to say that opposite over hypotenuse equals, and I want to find my 41-degree reference angle in my table, and it's right here. And the opposite over hypotenuse right here, this column here for the 41 degrees is 0.66 degrees. So I'm going to use that, and I'm going to substitute it in here. Okay. I said degrees, it's just 0.66. Okay. My adjacent over hypotenuse is 120 over something, or I could go back to my table. Adjacent over hypotenuse for my 41-degree angle is 0.75. So I'm going to use that, 0.75. Then I substitute in what I know. My opposite is Y. My hypotenuse is unknown. So I'm going to save that for right now. This is Y over something equals 0.66. So I have two unknowns. I can't do that one. So I'm going to check this one. My adjacent is 120. My hypotenuse, I don't know. So I will call that Z. So if we call this Y, and this is Z over here. So I have 120 over Z equals 0.75. And when I cross multiply, I get 0.75 Z equals 120. Divide both sides by 0.75. So really what we're doing is we're taking 120 divided by 0.75. And I get 160. There's my Z. So I can put that over here. my hypotenuse is Z. I'm going to replace this with 160. And then I can find my Y simply by taking 160 times 0.66 times 0.66, enter, and I get 105.6 meters. And this is meters. Okay, so what is the height of the building? The height of the building is Y. This is my actual answer here. The building is 105.6 meters tall. Okay, page 5 brings us to the end of lesson 25. Review the lesson summary. There is no lesson summary. Just go do your problem set.